Is it clear? Difference quotient. Yeah, it's here. So first we are gonna do, I'm gonna do one part. Let's take an example. Let me see if there is a difference question example. So 4x plus 3. 4x plus 3. They say find the difference quotient for 4x plus 3. The formula was, what we did is, so you have to remember this formula. It is f of x plus h minus f of x over h, where h is any number. I don't know what that number is, but it cannot be equal to 0. It cannot be equal to 0. It can be any number. It can be 1, 2, 3. I don't know as yet, but it cannot be equal to 0. So what you're gonna do is, so for what we need is f of x plus h and f of x. So this is your f of x. Okay, f of x is equal to, this is your f of x. So you're given f of x is equal to 4x plus 3. You needed two things. For this formula, you need two things, f of x plus h and f of x. F of x we already have in the question, 4x plus 3. We need to find f of x plus h. When you compare these two terms, what are you seeing? Here in the bracket I had x. Here in the bracket I had x plus h. So wherever you see x, you're gonna replace that with x plus h. Note, when you are replacing, always put in a bracket, okay? Always, whenever you're substituting value, I would suggest you to put in a bracket. That way you will never do mistake. You got this thing. Now solve it. Solve it. Distribute it. What does it become? 4 times x, 4x, 4 times h, 4h, and plus 3. There is no like terms. You cannot combine anything. Any doubt so far in this part? Or everyone got it? This one. Everyone got it? Okay. Next, what you're going to do is, you're going to, now once you found the value of x plus h, so you can say your step 1 is, if you want to write step 1, find value of f of x plus h by replacing x with x plus h in the equation. If you want to write stepwise, this is your step 1. If you want to make notes for yourself. So that's what I did here. Okay, so this is your step 1. Now your step 2 will be replace value of f of x plus h and f of x in bracket, right? In brackets. So you make sure you put in brackets in the formula. So whenever you are plugging in, make sure you put in brackets. So replace the values of f of x plus h and fx in the formula here, but you're going to put the values in bracket. So whatever was f of x plus h, whatever you found, put in a bracket here. So it becomes 4x plus 4h plus 3. Okay, I'm make sure I'm putting in a bracket, minus, make sure I'm going to again put fx also in bracket. Whatever is my fx, 4x plus 3 divided by h. Okay. Now let's solve it. Open the brackets now. 4x plus 4h, first brackets remain as it is. When you have negative, just a negative in front of a bracket, what you do is you change the sign of each and every term inside. Change the sign of each and every term inside. So this 4x is positive, this becomes negative. This is positive, this becomes negative, and divided by h. Combine the like terms. This is x term, this is x term. See, this is positive 4x, negative 4x. They cancel. There is no other h term, so my h term remains as it is. And then there is positive 3, negative 3. They cancel. So you are left with 4h divided by h. Now since 4 and h are multiplying, I can cancel the bottom h and this h, and I'm left with just 4. Any doubt? Any doubt? Anyone has any doubt in this problem? Let me know. And step 3 you can say is solve. And try to eliminate the h in the denominator. That's what I did. So you can, that's your third step if you want to write. Third step. Solve and solve. Once you write it in the formula, you have to solve, and what you are trying to do is you are trying to eliminate this h which is at the bottom. Any doubt? Anyone wants me to repeat this question? Everyone got this one? Okay. Let's do another problem I'm going to do here. Okay. So you are given fx is equal to 1 over x plus 3. I'm taking this another example. 1 over x plus 3. You are given fx. So let's write the formula here so I know. F of x plus h minus f of x over h. This is my difference quotient formula. Okay. What does my step 1 say? Find value of f of x plus h by replacing x with x plus h in the equation. So wherever it says I have to find the value of x plus h. How I do it is by replacing x with x plus h in the equation. So wherever I see x, I'm going to replace that with x plus h. Make sure whenever you are replacing, I again repeat, put in a bracket. So it becomes x plus h plus 3. You got this. Okay. What the next part says? Replace value of x plus h and fx in brackets in the formula. So this was my formula. So I'm going to plug in this formula here. So it becomes 1 over x plus h plus 3. Make sure you put in a bracket. I again repeat. Minus whatever was your f of x, put there. And divide. This whole is divided by h. Note in the numerator also have division sign. And then this whole thing is also divided by h. I don't like writing this way. I don't like too many division signs. What I'm doing is I'm keeping the numerator as it is. And I'm writing like this. Because this whole thing is divided by h. I can do that. If there is something like I say 5 divided by 2, the answer will be 2.5. If I write like this, my still answer is gonna be 2.5. It does not make a difference. It's still the same thing. But why I want to write it in this way? Because I don't want too many division signs. It's confusing me. Too many division signs. Now let's open the bracket. So it becomes 1 over x plus h plus 3 negative 1 over x plus 3. Then divided, this whole thing is divided by h. Okay. Now let's solve this. So subtraction, you cannot just subtract directly. For subtraction of fractions, you need to have the same base. You have this one has denominator as this one. This one has denominator x plus 3. If you know cross multiplication, you do cross multiplication. If you don't know cross multiplication, how you do it is, so this one has denominator x plus h plus 3. This has x plus 3. This thing does not have x plus 3. So what I do is, for this side, I multiply both my numerator and denominator with x plus 3 because this side did not have x plus 3. So this side did not have x plus 3. So I am multiplying my numerator and denominator both with x plus 3. And in this side, I did not have this part, x plus h plus 3. This was missing in this part. So I multiply that in both numerator and denominator. Make sure you have to multiply in both numerator and denominator. Okay, this is the only tricky part. Anyone who did not understand this part? This is the only tricky part. If you did not understand, you can unmute yourself and let me know. I'll explain. So now I made the common base. So now my base is the same. Here also x plus h plus 3 times x times 3. So I'm going to write it. So here is also, and here is also same. So I can just write it once. I can make a common base and write it like this. Since my base is common now, my denominator is the same. And the top one, what is 1 times this thing? Is the same thing, x plus 3. Minus, make sure I'm not opening the brackets. And here you have minus 1 times this thing, which is minus of x plus h plus 3 divided by h. Okay.
This is for dividing.
Yeah.
Does it say h plus h plus 3 or does it say h?
It's h plus 3 here.
Okay, yeah, because I can't read. Okay, that's right. I was confused.
It's plus.
Thank you.
Any doubt so far, anyone? Any doubt here? Okay. Now I won't suggest you the denominator. Don't touch the denominator. Leave as it is, the way it is. Don't touch your denominator. But I would suggest you to open your numerator. Open your numerator. You have to open because there's a minus sign. You have to open it. So let's see what does it become. It becomes x plus 3. I told you whenever there is a negative sign in front of the bracket, change the sign of each and every term inside. It becomes negative x, negative h, negative 3 over x plus h plus 3 over x plus 3 divided by h. See, combine the like terms. Positive x, negative x. They cancel. Positive 3, negative 3, they cancel. What you are left with only is, you are left with negative h over x plus h plus 3, x plus 3 divided by h. Now there is this division thing. How do you divide fractions? Fractions, how you divide is, you change the division into multiplication. How do you do that is, the first term remains as it is. You don't touch the first term. And I told you that division changes into multiplication. But when you change into multiplication, the next term flips itself. It flips itself. So here it was h. You're like, how am I supposed to flip it? What's at my bottom here? There's no denominator. There is a denominator. H is divided by 1. So flip it now. It becomes 1 over h. Let's see what you get here. So you get here. So see if you can cancel. If you can figure out if you can cancel something, cancel. See, here I had h. Here I had h. You're like, everything got cancelled. What I'm left with at the numerator? Let's see. You have a negative sign and you have 1. Multiply. Negative times 1 is negative 1. And at the bottom it is x plus h plus 3 and x plus 3. The main purpose of doing all this work was, I wanted to eliminate h in the denominator. I eliminated. See, I cancelled the h which we started from initially. I wanted to get rid of that. That's the purpose. And I got rid of the initial h which I had in the formula. This was the h which was dividing. This was the h which was dividing. And at the end, when I changed it into multiplication, it got cancelled. Any doubt with this problem? Anyone? And wants me to repeat any step? This kind of problem is very important. Any doubt? Everyone got this one? Okay. So next thing I'm gonna do today is domain. So generally your domain will always be minus infinity to infinity. Generally, I'm saying. First of all, what is domain? What does domain means? Domain means the values which I can put in the function. The values which I can put in the function and will give me an answer. Those are values are known as domain. So if you have an equation like I say fx is equal to 3 plus x, what will be my domain for this one? It says is all the values which I can put in x and it will still give me an answer. See here, I can put 3. I can take x value as anything I want. Anything I want. It will still give me an answer. So what are the x values I can take here is anything. So my domain becomes minus infinity to infinity. That means it could be any number between minus infinity to infinity. If I put in here, it's gonna still give me an answer. So the domain for this kind of function is negative infinity to infinity. Any doubt with what is domain? Okay, but generally the domain will be this thing, but domain changes in 3 cases. Domain changes in 3 cases. Okay, first you can say when the function has a denominator. Make sure you're making the notes for all this, because in book they don't write all this. So make sure making notes of all whatever I'm writing. So whenever the function has a denominator, my domain will change. It will no longer be
I got a question.
Yeah.
Would it be a good idea if you can send like the notes that you've written down on Canvas?
The ones, these things?
Yeah, the ones you wrote on Canvas.
Sure, I can post it, but I mean, I feel my writing is not clear, but I'll post it. If you want, yeah, I can do that.
Thank you.
Yeah, I'll do that, yeah, no problem. When the function has a denominator, then my domain is gonna change. Next thing is when the function has a square root. If the function has a square root, then also my domain will change. Third will be when the function has a square root in the denominator, then also my function will my domain will change. And the last one is combination of above. Combination of above. So these are the 4 cases my domain is gonna change. Example, let's do an example. You're like, how? Let's see what happens when I have a domain. What happens when I have a domain? Example, I have 3x, you're given fx as 3x over x square minus 4. You have this thing. Okay. Can anybody tell me for, what is 2 divided by, or you can say 4 divided by 2? Anybody?
Is it squared minus 4?
X square minus 4. It's x and then there's a 2 on the top minus 4. Can anybody tell me what is 4 divided by 2? Anyone?
2.
2.
2.
What is 4 divided by 0?
Undefined.
Yeah.
Undefined.
Undefined. See, I cannot have, for when I put my denominator as 0, my function is not defined. I told we will only take x values. So if my function is 4 over x, I will only take x values for which my function is defined. I cannot take for which my function is not defined. So my denominator can never be equal to 0, because then it will make my function undefined. So in this case also, everything is possible. I will take all x values from negative infinity to infinity. but I will not take x values which will make my denominator as 0. I cannot take x values which will make my denominator as 0. So in generally my domain will be negative infinity to infinity, but since I have a denominator, my denominator cannot be 0. What will be the value of x which will make my denominator 0? Which value of x will make my denominator 0?
2.
Yes. But how do you calculate it? How do you calculate that? How do you do it is, whenever you see a denominator, so step 1, so in this case, whenever you see a denominator, you see a denominator. Put the denominator, just the denominator, equal to 0. Put the denominator equal to 0. So in this case, my denominator is x square minus 4. I put it equal to 0. Step 2. Solve for x. Solve for x. So I had x square minus 4 is equal to 0. I add 4 both sides. I get x square is equal to 4. Note, now opposite of square is square root. I am going to take square root on both sides. I am taking myself. So I have to put a plus minus sign. Don't forget this step. You have to put a plus minus sign. You get x is equal to plus minus 2. So at these 2 points, x is equal to plus minus 2, my domain is not valid. If I put this x plus 2 here, my denominator becomes 0. If I put negative 2 here, my denominator again becomes 0. My function will not be defined. So now if I make my number line here, so I said minus infinity to infinity, all numbers are included, but negative 2 and 2 are not included. But these two are not included. Now my domain is divided into 3 parts. 1, 2, 3. So let's write those 3 parts. First is negative infinity to negative 2. Then is negative 2 to 2. Then is 2 to infinity. And you write it with the U symbol. Union. Any doubt with this problem? So whenever you have denominators, put it equal to 0, solve for x, whatever values you get, write it on the number line, and then see how many parts your number line is divided into. Write those parts separately with the union sign. Any doubt? Can everyone do me one problem? I want you to do this problem. Fx is equal to, I want you to find the domain for this one. Fx is equal to x over x square.
Can you go back to the previous page? I need to finish up the second step.
Yeah, sure. I can do that. Just a second. Let me see. Everyone else, if you're done, I want you to start doing the problem on the top. Fx is equal to x over x squared minus 16. Yasmin is not here. Eduardo,
Yeah.
can you help me with this problem? How to do it?
I'm currently writing down right now.
Okay, you're writing as it. Okay, do it. Alejandro, can you tell me how to do this problem?
Yes, I can.
Yes.
So you first set the denominator to equal to 0
Okay.
as your first step. So it'll
Okay.
be x squared minus 16 equal to 0.
Mm-hmm.
And then you solve for x.
Okay.
You add 16 on both sides.
Okay. What do you get?
And it will be x squared equals 16.
Okay.
And then from there, you keep solving for x, which is find the square root of both sides.
Okay.
And then that will equal x equals plus or minus 4.
Yeah. So whenever you take square root, you put plus minus. Yes. Perfect.
Mhm.
So what's my domain?
And then the domain should be under brackets negative infinity comma negative 4.
Mm-hmm.
And then negative 4 comma 4, and then 4 to negative infinity, and then all connected with the u.
Okay. So it was these three parts, and then he writes the first one, then the second one, then the third one, and they're connected with a u sign, which is union. We call it union. Thanks, Alejandro. It's really good. Anyway, any doubt with this thing? Anyone? Everyone got this example? Okay. So we are done with the first part here. It says when the function has a denominator. So in wherever you wrote this, write, put the denominator equal to 0. Denominator equal to 0. So whenever you have a denominator, you're going to put the denominator equal to 0 and solve and exclude those points. Next point is when you have a square root. Maybe you should write when you have a square root in the numerator. I want you to, in the second step, I want you to write in the numerator. Change this here. Write when the function has a square root in the numerator, just to be clear with what I'm saying. So when you have a square root in the numerator, like, and take an example. I take an example. You are given as fx as square root of 4 minus 3t. Or f of t. I say f of t. In place of x is as t. It does not matter which variable I'm taking. F of t is equal to square root of 4 minus 3t. Now you have a square root in the numerator. Note, my square root is not at the denominator, it's in the numerator, it's in the top. You're like, there's no denominator. It's okay, if it's not, there's no denominator, it's still in the top. Okay, what you're gonna do in this case is, can anyone tell me what's the square root of 4? What's the square root?
2.
What's the square root of negative 4?
-2. -2.
You know the thing is,
It's
for square root
Plus or
of
minus 2?
no, square root
Two
of
pi.
negative numbers is not defined. So you can make a self note for your note for yourself here. Square root of negative numbers is not defined. Square root of negative 4 is not defined. Square root of negative 8. Square root of negative 10. Nothing is defined. Only square root of positive numbers is defined. You will say, what about 0? What is the square root of 0?
Not defined.
No, 0 is 0. Only negative numbers is not defined. It can be 0, but it cannot be negative. So you can write, it can be 0 but not negative. It can be 0 but it cannot be negative. Always remember this property of square roots. My square root, inside my square root, I know the values for positive numbers. I know the value for 0, but I don't know the value for negative numbers. So everything will be included in my domain. here 4 minus 3t, everything will be included, but this thing cannot be negative. It can be 0, it can be 0, but it cannot be negative. So what will be my domain will be, I told you 4 minus 3t. So whatever is inside the square root, whatever is inside the square root, note when my square root is in the numerator, what we are gonna do is my domain will be everything which is in the numerator, inside the square root, not the numerator, inside the square root, you're gonna put it greater than equal to 0. That means it should be positive. It should be either greater than 0 or equal to 0, because it cannot be negative. That will be my domain. Any doubt why I'm putting greater than equal to 0? Anyone who did not understand this? Because inside the square root I cannot have negative signs. That's why inside should be either greater than 0. It can be 0 also, because I know which is 0. So now I'm going to find the t values. So first let's solve for t. I subtract 4 both sides. I get minus 3 greater than equal to negative 4. There is a very interesting thing about inequality. There is a very interesting thing about inequality I want you to write in a bracket here. Whenever you multiply or divide yourself an inequality with a negative number. Note I'm writing negative number here big. This is important. When you're multiplying and dividing only. If you're multiplying and dividing yourself, the inequality. See, this is inequality because it's not just equal to sign. If it's just equal to sign, then you can do whatever you want. But since there's an inequality here, there's a greater than equal to sign. You flip the inequality sign. That is, this will change to this or vice versa, or this will change to this. So now in this case, now I have to solve this further. I just need t. Minus 3 is multiplying with t. So what I'm going to do is I'm going to divide both sides with negative 3. Note I'm dividing with the negative number. So I need to flip this sign. So I need to flip this. It will change to this thing. So you get t less than equal to 4 over 3. Negative negative becomes positive. Now what is 4 over 3? You don't know. You're like, let's convert in decimals. It will become easier to know where it's on the number line. It's 1.33. You can use a calculator and see. You'll get 1.33. Draw on the number line. Where is 1.33? Less than 1. What are the values less than 1 by 33? What are the values less than 1.33?
Negative infinity to 1.33.
Yes, exactly. So all the values which are less than this side, they are talking about this side, including this number, note there is an equal to sign here, including this number. So it will be negative infinity to 1.33, but at 1.33 your bracket will be the square bracket. Square bracket means this number is included. If I don't put a square bracket, that means this number is not included. Any doubt with this example? Okay, everyone got this one? Okay. I want everyone to do this example here. I'm going to write fx is equal to square root of 1 minus x. Square root of 1 minus x. Everyone do that. Joshua, you're gonna help me.
Alright. Please write it down.
Okay, so how do we do this problem?
Well, since you're square rooting it, wouldn't you have to put one of the symbols that you said to use, or one of the signs?
Mm-hmm. So
So would
what's my first step?
it be the 1 minus x is greater or equal to 0?
Yes, perfect.
Then you would get the 1 to the right side, so you subtract 1 from both sides.
Okay, I subtract 1 from both sides. What do I get?
Negative x is greater than or equal to negative 1.
Okay. What's my next step?
So do you need to get rid of the negative x?
Yes, negative number, not the x, just a negative number.
So when you divide both sides by negative, be x equal 1, or is greater than or equal to 1?
So basically, how do you get rid of the x? Either you multiply by negative 1 or divide by negative 1. What are you gonna do, Joshua?
Divide by negative 1.
Okay, so you're dividing both sides with negative 1. So what happens when you divide with a negative number?
It changes positive.
It changes positive, but what else?
It's undefined.
No, it's not undefined. Remember, I told you this here.
You gotta flip the sign.
You're gonna flip
Oh.
the
You gotta
sign.
flip the graders in it.
Don't forget this. In inequality, when you're dividing or multiplying with a negative number, you have to flip the sign. So it becomes x, you have to flip this sign now. It becomes less than equal to 1.
Oh, okay.
Yeah. And now, can you tell me the domain? So this is your 1, this is your negative infinity. Here it's always infinity. So what it will be?
It would be pointing to, I think it's the left, right?
First of all, you tell me what are the numbers less than or equal to 1.
Negative infinity.
So negative infinity to
1.
1. And what kind of bracket will I have on 1?
I'm sorry, what?
What kind of bracket will I have on 1? Bracket. What kind of bracket?
Oh, wouldn't it just be a parenthesis?
So it will be this thing. It will be this bracket. The reason I'm putting this bracket is because this point is included. Note, there is an equal to sign, right? That means this point is also included. So if I put this bracket, that means my 1 is also included.
Oh, okay.
If I put just this bracket, that means my 1 will not be included.
Oh, okay. Makes
Okay,
sense.
that's the difference between this bracket and, so this thing is known as open brackets. Endpoints not included. This thing means closed brackets, we call it closed brackets. Endpoints included. And then you have this thing. Partially, you can have like this also. So wherever this is closed, that point will be included. This point will not be included wherever it's open. Partially open and partially open, closed.
Okay.
And negative infinity to infinity. Negative infinity always. So wherever you see negative infinity, that will also have open bracket. Wherever you see infinity, that will always have open bracket. So negative infinity and infinity always have open brackets next to them. These are the rules for brackets, if you don't know. Okay. The last kind for this one domain is, when they say third type we are doing. Now we have when the function has a square root in the denominator. What do you do that? When you have in the denominator. Example, let's take an example. I have, let me see if I have example, square root in the denominator. Okay, you have you're given fx is equal to x over square root of x minus 4. Note here I have a square root in the denominator. What happens? Anyone knows anything when what happens when you have a denominator first of all? What happens when you have a denominator?
N equals 0 or it's undefined?
Yes. My denominator, note, we did. When we had a denominator, my denominator cannot be 0. And whenever I had my square root, whatever is inside my square root, that cannot be a negative number. So my denominator, since I have my denominator cannot be 0. So my this thing, I know. So my this thing cannot be equal to 0. Because that will make my denominator 0 and my function undefined. Also, whatever is inside my square root, that should be greater than equal to 0. First of all, they say this whole thing should not be equal to 0. And then you are saying at the same time whatever is inside should be greater than equal to 0. If I combine these two, what happens? I basically get rid of this equal to sign. So basically what happens is, what you're going to do is, so whenever you have a denominator, so whenever you have a square root in the denominator, put whatever is inside the square root strictly greater than 0. Strictly greater than 0. You will not put greater than equal to 0. It will be strictly greater than 0. There is no equal to sign because it cannot be equal to 0 because it's in the denominator. If you put in the denominator, this function will become undefined. It should be just strictly greater than 0. So what's in my denominator? Whatever is inside my square root, I'm going to put it strictly greater than 0. Now solve for x. Add 4 both sides. You get x greater than 4. Solve. Minus infinity, infinity, and 4 is here. Greater than 4 values are this side. So my domain is 4 to infinity. Is my 4 included in this case? 4 is not included because there is no equal to sign here. So my bracket will be open. Any doubt?
Why would your bracket be open again?
Yeah, see in this previous problem here, see, I had equal to sign, right? So wherever there was 1, I closed it. That means my 1 is included. X can be 1 also because there is the equal to sign. Okay, what does this sign mean when you write in words? If I write this in words, what does it mean? X greater than 1, or my x can be equal to 1 also. That's what it means. Okay, that's why x can be equal to 1. That's why I put it in here. But in this case, in this example, it's just greater than. There is no equal to. My x cannot be equal to 4. It has to be greater. It can be 4.001, but it cannot be 4. That's why at 4 it's open. Did you get it? In one time?
It's open. So I know that if it's open, then it would have the endpoints not included. So that means that the endpoints aren't included for
Yes.
the 4 to infinity?
Yes.
Okay.
Yeah.
Okay.
So whenever you have denominator, you'll always have an open. Whenever it's in the numerator, you'll always have closed in one side. Any doubt with this example? I want everyone to try this example I'm giving here. So you will be doing negative x over square root of negative x negative 2. Except Chris, I want everyone to join with video. I don't want just your some photo or something like that. I want everyone to join with their videos. Except Chris. I want their videos on. Okay, Angel, help me out. What I'm gonna do?
First we gotta get negative x minus 2 and then have it greater than 0.
Okay.
We'll move the negative 2 to the other side.
How do I do it?
We add 2 on this side.
Okay, perfect. You get?
That negative x is greater than negative 2.
Negative 2?
Oh, sorry, 2.
2, okay. What else?
Do
Mhm.
what's it called? I don't know what that was called.
How do I get rid of this negative sign? Either you multiply with negative 1 or divide by negative 1.
Oh, okay.
What do you want to do?
Could multiply negative 1?
Okay, you're multiplying with negative 1. I multiply with negative 1 this side, negative 1 this side. What happens when you multiply with negative 1, Angel?
The sign.
This what happens to the sign?
It's gonna be x has to be less than negative 2.
Perfect. Yes, you have to, when you're multiplying or dividing with the negative number, you have to flip the sign. So let's see. Let's make negative infinity, infinity, and then you have 2. Which side of 2 is less than negative? Oh, sorry. Which side of negative 2 is, x is less than negative 2?
Yeah, so it's going to negative infinity.
2?
To negative 2.
Yes.
Yeah.
And what will be the brackets?
What are they called?
Open. Yes. They're going to be open. They won't be closed because there is no equal to sign. And infinity is always open. But here I have open because there is no equal to sign. Perfect. Perfect, Angel. Any doubts?
Just to clarify,
Yeah.
Square root in denominator is always open and square root in numerator is always closed?
Yes.
Okay. Thank you.
Yeah. And you can have combinations. Let's do one more example where there is combination. Let's do example. I'm going to do one example and then you're going to do it. Suppose you're given as pt is equal to square root of this thing over 3t minus 21. Note in this case, two things are combined. So we had these three conditions. I cannot have a denominator. If my square root is in the numerator, it should be greater than equal to 0, or if it's in the denominator, it should be strictly greater than 0. Here I have a denominator. So when you have a denominator, what do you do? Anyone? When you have a denominator, what do you do?
Set it equal to 0.
Yes. So here denominator is 3t minus 21 is equal to 0. Do you see any other condition? There is a square root also in this problem. But square root is where? It's in the numerator or denominator?
In the numerator.
What happens when it's in the numerator?
It can be equal to 0.
It can
or
be
it
equal.
can't.
No.
It
What do you do
can't.
when it's in the numerator?
It can't be.
Oh, wait.
It should always be positive, right? It can be 0, but it should always be positive. I told you when it's in the numerator, you put it greater than equal to 0. If it's in the denominator, strictly greater than 0. Remember like this. So these are the two conditions now. Let's solve for both problems you're going to solve for t. Let's solve this one first. Add 21 on both sides, you get 3t is equal to 21, and t is equal to, divide by 3, you get t is equal to 7. So let's start drawing number line. I got 7 here. Note this 7 should not be included, because if I put 7 here, it is making my denominator 0. So I'm making an open circle. So I know this thing is not included. I don't have to include this in my denominator. Let's solve this thing here now. Add plus 4 both sides, you get t greater than equal to 4. 4 comes before 7. T greater than 4, and include, there is an equal to sign. So my 4 is included. I make a dark circle there. Because my 4 is included, there is an equal to sign there. Greater than 4 means it's from here to here. That's my answer. But note, my answer is this, from here to here is my answer. But this point should not be included. 7, except 7. 7 is not included. So my domain is divided into 2 parts now. 4 to 7, and then 7 to infinity. Infinity I know is always sign this thing. 7 is not included, so it will be open. 7 will always be open, because my 4 is included, so my bracket will be this thing, and you put a union sign. Any doubt with this problem?
Can you do another one, please?
Yes, I'll do another one. Example. The same kind you want? Okay, I want everyone to try this. H of z is equal to z plus 3 over z minus 2. I want everyone to try this, and then I'm going to go through this example.
Is that z minus 2 on the denominator?
It's z minus 2, yes.
Thank you.
Axel, you're going to help me with this. So Axel, what's my first step?
Make it denominator equal to 0.
Axel.
Yes. Hello? Hello?
Hello?
You hear me?
Yeah.
Okay. You make the denominator equal to 0.
What do you get from there?
It's z minus 2 equals 0.
Yeah.
You add 2.
Okay.
It's positive 2. Z equals positive 2.
Z is equal to positive 2. Let's make on the number line, I put 2. Okay. Since I got 1 as 2, I put it. Is 2 my included or no in the domain?
Pardon?
2 will be included in my domain or no?
Yes.
It will be included in my domain?
No.
It won't be included in my domain. Then I make a... Since it won't be included in my domain, I'm going to make a open bracket here. Okay. The reason it's not going to be put in my domain, because if I put 2 here in my denominator here, it will make my denominator as 0. And I cannot let that happen. So it will be open. What's my next step?
You put 2 on the numerator.
Yeah. So
Square root of 5.
So what do we do? Can you tell me? What should I write?
It would be 2 plus 3 on the numerator.
Z plus 3. Z plus 3.
Oh, z plus 3.
Yeah. Should be?
You put a 2 on the z, no?
Whenever you have in the numerator square root, what do you do?
Excuse me?
Whenever you have numerator, in the numerator you have a square root, what do? You put it greater than equal to.
Greater than equal to 0? Or?
Yeah. Greater than equal to 0, always. And if it's in the denominator, then strictly greater than 0. There won't be any equal to sign. But if it's in numerator, it's equal to, greater than equal to 0. Then solve. Subtract 3, you get z greater than equal to negative 3. Negative 3 is here, and it's this side. Now, there is an equal to sign. That means my negative 3 is included. And Wandi, did you get it?
Yeah.
Yeah. And Wandi, you asked, right? Or someone else asked?
Oh, no, I asked for that.
Okay.
Thank you. I understand now.
Did you? Okay, you understood. So now my negative 3, there was equal to sign, so negative 3 is included. So my domain is divided into two parts here. Negative 3 to 2, then 2 to infinity. No, 2 I don't want, so I'm going to make an open bracket. Infinity is always open, but negative 3 I want it, so it's going to be closed.
Close bracket.
Yes, perfect. Any doubt, anyone, with this example?
So just to clarify, if it's an equal, if it's like an equal or it's greater than an equal, it can be a part of the denominator.
When it's in the denominator, it will be strictly greater. Then my 3 won't be included. My 3 will also be open.
Okay, so you didn't put the 2 inside
Yes.
of the closed bracket because it's on the numerator. It was a part of the numerator.
Denominator.
Denominator. Okay, so the numerator is what you put with
Greater
the bracket.
Yes.
With the closed bracket. Okay.
Yes.
Thank you.
Yeah. Any doubt, anyone? So next thing what we're gonna do is, next thing I'm moving to is, let's see, here is, now you're given graphs. So there's something known as vertical line test. Vertical line test. What it says is, now you'll be given what does this vertical line test do. I'll give you definition, but you should know what does it do. What it will do is, you will be given a graph. You will be given a graph. You have to tell whether the given graph is a function or not. So basically what do we use vertical line test for is, you'll be given a graph. You'll be given a graph, and then you have to figure it out whether it is, you know, your, just a second. You'll be given a graph. You have to tell whether it's a function or not. How do you do it is, so the definition, first I'm going to write the definition. A set of points in the xy plane is the graph of a function. So it's a function if and only if, so basically you don't get confused between a set of x, just remember from there, the graph of a function if and only if every vertical line intersects the graph in at most one point. So this is a basic definition. Don't get confused with the first, these a set of points in the xy plane. Don't get confused by that. Remember, a graph is a function. It is a function if and only if every vertical line intersects the graph at most one point only. It should cross my graph at only one point.
So we can basically use the function method instead of, so you don't have to actually graph it at all?
Yes. So example, let me take example. Let's see. I have this graph. I give you this graph. I say my graph looks like this. This is the graph I've given to you. Okay. I say, tell me, by looking at this, by applying the vertical line test, tell me whether this thing is a function or not. What you're going to do is, you're going to start drawing vertical lines. Let's draw. Here it's not cutting the graph at all. Here, see, when I'm drawing vertical line, here it's crossing at one point only. Let's draw more vertical lines. Still crossing at one point only. It's crossing my graph at one point only. Let's draw another vertical. It's still crossing at one point only. 1 point only. No matter where I draw my vertical line, it's just crossing my graph at 1 point only. If it's doing that, if it's crossing at 1 point only, it is a function. It is a function. You'll get one more example. You'll get to know when it's not a function. Suppose I draw one more. I draw one more, something like this. Now my graph looks like this. I want to check whether this thing is a function or not. Start
Miss
drawing.
K,
Yeah.
can you go back to the definition really fast?
Yes.
Thank you.
Yeah. So for this one, I have to check whether it's a function or not. Start drawing vertical line. See, when I draw vertical line, what happens? It's crossing my graph at 2 points. This is my graph. It's crossing here also. It's crossing here also. If my vertical line cuts a graph at 2 points, it is not a function. Did you get it or no?
Yeah, I got it. Thank you.
Anyone has any doubt where by seeing the graph whether it's a function or not? So this is simple. This vertical line test is very simple. You just have to figure it out. Okay. Can I have, let's see, Samantha. So if I have like this, can you tell me whether it's a function or not?
No.
It's not a function.
It's not a function because it crosses 2 points.
Yes, if I draw a vertical line, see it's crossing at 2 points. This point also and this point also.
Yes.
It's not a function. Perfect. Not a function. Perfect. Okay. So let's do one more problem here. Okay. I'm gonna show you here. So now you're gonna tell me, okay, first all these problems, we're gonna solve these problems here. I'm gonna call your names and you're gonna tell me what it is. Karen, is Karen here?
Yes.
Okay, Karen, can you tell me, so it says, the graph is given to you here. Graph is given to you here. They say, what's the value of f of 0? F of 0. Can you tell me what's the value of f of 0?
0.
So how do you check is, no, before I check it, how do you check it is, okay, where is the x value 0? F of 0. So note, usually we write it like this, right? F of x, right? We write it like this, right? But they are asking you to find f of 0. So basically they're asking you, when you put your x as 0, what do you get the value of y? So you tell me, where did you put your x value as 0? See, x is 0 where? X is 0 where? Where is x 0 on the line here? It is here. And what's the y value? See here, 4, exactly. So f of 0 is 4. Perfect. Okay, can you tell me f of 3 pi by 2? Where do you see 3 pi by 2? X as 3 pi by 2.
0.
Yes, it's here. See, my x is 3 pi by 2 and my y is 0. Okay, can you give me one more example? Is what's f of 3 pi?
No worries. -4.
Yes, perfect. You got it. I got it. Perfect. Any doubt? Anyone who did not understand how I'm getting these values? So wherever is 0, you see what's your y value. Wherever is 3 pi by 2, if they're asking what's the y value. Wherever it's 3 pi, they're asking you what's the y value. Okay. Next thing they want to ask is, what is the domain of f? What is the domain of f? You have to tell me what's the domain of this function.
Is it 0 to infinity?
No. The
No,
graph is
it's 4 to -4.
No. Where you see
Is it
only
four?
when you're finding the domain. No, when you're defining the domain, just see the x-axis. I'm not consider about y-axis. From where to where is it going on x-axis?
0 to 4 pi.
Yes, exactly. It's going from 0. It's starting from here, x-axis, which is 0, and it's going all the way till here, which is 4 pi. So my domain is 0 to 4 pi. Anyone who did not understand? Okay. So what is a range? So domain is basically x-axis. Range is basically
The range will be the 4 to negative 4.
range of f. So my range is basically y-axis. So see, it's going from here to here. See. So it is negative 4 to 4. You always write the smaller number first, then the higher number. Anyone who's having any doubt with these problems?
For the domain of f,
Yeah, domain
Is
of
it
f, yes.
the one
Domain
that you first, is it like the first point that would be for,
x.
that would be x?
Yes.
So
And the
domain
last
would be the
point.
first point that you see on there.
Yes. For domain you see x-axis, for range you see y-axis.
Okay.
Yeah. Okay. Next thing point says list the intercepts. List the intercepts. First of all, can someone tell me what's the intercepts? What
The points on the graph?
The points that cross the x-axis
or y-axis?
or y, yeah.
Yes. So can someone tell me what are the intercepts? See, let's see the y-axis. Where is my graph crossing the y-axis?
0, 4.
Yeah, so one point is 0, 4. That's it for y-axis. What about x-axis? Where is my graph crossing the x-axis?
Where your
Pi by 2, 0. See, this is the first point it's crossing. Then this is the second point, 3 pi by 2, 0. Then 5 pi by 2, 0. And then the next one is 7 pi by 2 and 0. Anyone has any doubt how to find intercepts? Intercepts, just see where x-axis and y-axis and where is my graph touching the x-axis and y-axis. Okay, next question they ask is how many times y is equal to 2 crosses the graph? Y is equal to 2. So if y, where is y is equal to 2, if I draw a y is equal to 2 line, how many times will it touch my graph? Anyone?
Once.
So see, let's see.
4 times.
See, my graph look like this, right? It looks like this. Yeah, it looks like this. And my y is equal to 2 is here, right? Y is equal to 2 is here. Let's draw a line here. Y is equal to 2. I'll draw a line here. I drew it here. How many times is it crossing?
Yeah.
4 times?
4 times. So it will be, answer will be 4 times. It says next question is for what value of x does fx is equal to negative 4? Can anyone tell me? For what values of x my fx is negative 4? By fx they mean y. For what values of x my y is negative 4? Fx, y, they are the same thing. For what values of x my fx is negative 4?
So 0, 2 pi, and
Negative
4 pi.
4. Negative 4. Y is negative 4. Y is negative 4 is here.
Oh, y is negative 4? Okay, sorry. So pi and
Negative
3 pi.
4, 3
3 pi. Only pi and 3 pi. See, where is negative 4? Negative 4 is here. Which points? These 2 points are only negative 4. And what's the x value at negative 4? Pi and 3 pi. So that's my answer. Anyone who did not understand this part? For what values of x? For what next part? What values of x? Fx is positive. I mean fx is greater than 0. That means positive. For what values of x is greater than 0?
4 pi and
It's saying for what values of x my y is greater than 0. What values of x?
0, 2 pi, and 4 pi.
So note, this is not points. Greater than 0, if you
Oh,
see, it will be range. So for this to...
Oh, I see what you mean. Yeah, so it'll be the other way. Yeah, I got you. So it'll be, I can't see those. Pi over 2, 3 pi over 2, and the last one I can't see. Sorry.
So, okay, I want you to see. Okay, let me explain this. When they are asking you greater than 0, they are not just talking about the points which are marked. There are many other points which are greater than 0 also. So you had graph like this, right? So your graph looked like this. So which is, I know my y values, all this underneath here, underneath all these are negative. So I don't want these. I want fx y values which are positive. So all these on the top. For what values of x? This value for this, for all these, my y value is positive. If I take this, my y value is positive. For this point, my y value is positive. For this point, my y value is positive. Even within this range, my y value is positive. Even for this range, my y value is positive. So it will be in a domain form. So it will be 0 to, this thing is pi by 2. So 0 to pi by 2. Okay. And then pi by 2 to 5 pi by 2. Oh, sorry. Yeah, 5 pi by 2 and then 7 pi by 2 to, yes, 7 pi by 2 to, it's going to 4 pi.
On the 0, is 0 included?
Yes, it's going to be included. I'm sorry, I did not mark. It's going to be included. It's going to be all included. All included. Anyone who did not get this part, why I marked, it's in interval form. We are not just talking about points. We are talking about intervals. They are in this problem before they were saying fx is -4. They are asking about specific point, but they are asking greater than 0 now. They are asking many points greater than 0. It could be 0.222, 0.333. It could be anything. Anyone has any doubt how I got this?
Isn't it in parentheses for 2 pi though? Because it's not equal to 0.
At 2 pi.
I mean, sorry, not 2 pi. Pi halves.
Pi halves, but pi half the value is 0, right?
Yeah.
Oh
But
yes. Oh yes. Oh, I agree. Someone, it's correct. So see, at 0, what's the value? So you had 0. That's correct. Someone corrected me. I'm glad you corrected me for this thing. And then you have 7 pi by 2 and then 4 pi, right? These were the intervals. 0, what's the value at 0? 4, right? Which is definitely greater than 0. So that means you make a close bracket at 0. What's about pi by 2? What's the value at pi by 2? What's the value at pi by 2?
0.
0. And note, they're asking you strictly greater than 0. They're not asking you equal to 0. So that means it's going to be open bracket at pi by 2. And then you have 3 pi by 2 to 2. 3 pi by 2 again is 0. So it's going to be open. 5 pi by 2 is also 0. This is also 0. And at 4 pi, it is 4. So it's going to be closed. So that will be your answer. I'm sorry, you have to check what's the value, and they're asking you strictly greater than 0. Strictly greater than 0. It's this answer. If you did not understand, I can explain again. Okay. Everyone got it? Okay, I want you to try this problem here. Okay. Example 2. Example 3. Example 3. Example 3. Start doing the example 3. Was here? Was back?
Yes.
Yeah. Okay. So first part, you're given the function. What's the domain?
Uh, -2
So how did you get that -2? Can you tell me?
from the denominator.
So what did you do with the denominator?
X plus 2 equals 0.
Okay, you put x plus 2 is equal to 0. What did you get?
-2.
X as -2. Then what's your domain? Yeah, you're correct.
Yeah, negative infinity to -2.
And what kind of brackets?
Open.
Open, okay. Is there any other?
Yes, union, then -2 to 1.
To infinity. See, only these are those two intervals, right?
Yeah.
Yeah. And 2 is not included. Okay, perfect. You got it. Shaira?
Yes.
Okay. Can you tell me the next part? Is the point 1 and 1/2 on the graph? How do you check whether that part, this point is on the graph or no? How do I check? Put this point in the equation. Put this point in the equation and see if you get your answer or no. Okay, if it's the same or no. Basically, first one is your x and second one is your y. Y and fx is the same thing. Y or fx, they are exactly the same thing, always. So wherever you see fx, you're going to write there 1/2. And wherever you see x, you're going to write what? What's your x? What's your x in this point?
1.
1. So you write 1. 1 plus 1 over 1 plus 2. Which is equal to, you get, your right hand side is half. What does this become? What is 1 plus 1?
2 over 3.
Are they the same?
No.
No. So that means the point does not lie on the graph. If they are exactly the same, the point lies. But if they are not the same, my point does not lie on the graph. Anyone has any doubt with this one? Samuel? Samantha?
Here.
Okay. Samantha, can you tell me the next one? If x is equal to 2, what is fx? What point is on the graph of f? Okay, if x is equal to what is fx, how do you find that?
You plug in the x.
Yes, perfect. How do you do it? Fx is equal to what does it become?
Excuse me?
So what do I plug in x as 2, you said, right? So plug in x as 2, what do you get? F of x is equal to?
My dog is crying.
So you put x as 2, wherever you see x, you put 2. See, this is your function, right?
Yeah.
Put x as 2, what do you get? 2 plus 1 over?
2 over x.
X is what?
Oh, 2.
Yeah. 2 plus? 2.
So it will be 2 plus 2.
It will be what?
2 plus 2.
Yeah. So what does it become? What is my numerator?
3
over
4.
Yeah, perfect. That's your fx. So if f is equal to fx is equal to what is x? Now they're asking you if fx is equal to 2, what is x? Angel? He's not here. Beneath. Miguel.
Yes.
Okay. Can you help me with this? If fx is equal to 2, what is x?
It will be 2.
So how do you do? 2 is, you are saying fx is equal to 2. So you get 2 is equal to,
2? Wait.
you have to find the value of x. You are given fx.
Mm-hmm.
So you get what? How do you solve it? 2 is equal to, you don't know x, we are finding x, so we write it like this. And then we solve it for x.
Okay. So
x by 2 is dividing, right? So I multiply x by 2, so I can get rid of x by 2 from the denominator. Okay. So this and this gets cancelled. So here you are left with 2x plus 2 is equal to x plus 1. Then solve. What does it become?
then 2x plus 4.
Yeah, is equal to x plus 1. Then solve.
Then you subtract 4.
Okay, you subtract 4. You
Both
get
sides.
2x is equal to x minus 3. What else?
And divide by 2.
No, first take x terms one side. Here x is adding, right? You subtract x. First take x terms on one side.
Okay.
What is 2x minus x?
X.
Okay, x is equal to negative 3.
Negative 3. Okay.
Now in the question they are also asking you what point is on the graph. On the graph will be, first you write the x point and then the y point. Y was given to you as 2. X you found right now as negative 3 and fx was, which is basically y, was already given to you as 2. So this is the point which lies on the graph. Anyone has any doubt with this one? Hugo? Hugo? Hugo is not here. Chris?
I'm here.
Okay. Chris, can you tell me the next part? What are the x-intercepts of the graph? How do you find x-intercepts?
By equaling it the y to 0.
So what do you put y to 0? What do you get here?
So if y is equal to 0, you equal it to x plus 1 over x plus 2.
Yeah.
Then you solve for y, which is 0.
Yeah, so what do you get?
One sec. Actually, wouldn't that just be hold on.
See here, x plus 2 is dividing, right? I don't want the division thing. Let's get rid of this. I multiply both sides with x plus 2. Here they get cancelled. 0 times x plus 2 is what?
0.
Yeah, you get 0 is equal to x plus 1. What do you get x as?
So x minus 1.
Yes, you subtract 1 both sides, you get x is equal to negative 1. This is your x-intercept. But next part in the question, they are asking you what points are on the graph of f. If they are asking you points, write it in the coordinate form. Your x was negative 1 and your y was 0. Yeah, that's your coordinate. Any doubt so far? Anyone?
No, going fine so far.
Okay, so we completed section 2.2 and section 2.1. So tomorrow I'm gonna start section 2.3. I did not finish section 2.3. Anyone has any doubt? Am I going too fast for someone, or I'm going too slow? or you're not able to understand?
I just had a quick question.
Mm-hmm.
How are the quizzes for Thursday gonna go?
For the quizzes?
Yeah, how are you gonna do them?
So the quizzes, how you're gonna do it is, so it basically you don't have to come on, I'm gonna see, it's like, I'm gonna tell you about the quizzes. I don't know you're gonna have this time quiz because I'm going slower. I was supposed to complete section 2.3 today. I did not finish section 2.3. You will have the whole day to take a quiz, but there will be time limit. So like you have 30 to 40 minutes to do it, and you can take any time during the day. That's how, and you don't
Okay.
have to come on Zoom. No, you don't have to be on Zoom for quizzes. For exams, yes, you have, the exams will be at specifically this time from 7 o'clock to 8:25. You don't have to be on Zoom. You will do the exam on my lab and show me the work. You will do your work on a paper and take photos later once you're done with your exam. Take photos and send me through email. But for
Alright.
quiz, you don't have to do that.
Thank
Yep. Anyone else? Any doubt? Don't leave. I have to take attendance. Anyone has any doubt? If you have any doubt with homework, please email me. You can email me. Take the screenshot of the the question. Text me. I'll send you the solution, or I'll call you or help you out. And whenever you message me, make sure you write your name and the course number. I'm teaching so many courses, so I don't know which course are you from. So make sure you write 244. Okay. Yasmin, Eduardo,
Yeah, here.
Karen,
Here.
Roz, Shira,
Here.
Samuel, Samantha,
Here.
okay, Angel,
Here.
Benit, Miguel,
Here.
Hugo, you guys know how to. Chris is here, Joshua,
Here.
okay, Erica, Gerald, not here, Daniel,
Here.
okay, and then Gerald here or Daniel here?
Daniel.
Daniel, okay. And Wandai,
Here.
Jesse, Jose,
Here.
Alejandro is here, Giselle
Yes, I'm here.
is not here, Axel,
Here.
Jelena,
Here.
Carly,
Here.
Hawking,
Here.
yeah, okay.
Here.
Perfect. Okay, sure. You can go, and I'm always here like 15 to 20 minutes before class also. If you have any doubt, you can come at that time, and if you want to stay right now, you can stay. I'll help you. Thanks. Have
Thank
a
you.
nice day, guys.
You.
Yes,
Oh, wait.
see you tomorrow.
Bye, Miss K. Have a good day.
Yeah, you
Wait, I have a
too.
question.
Yeah, Joshua.
So wait, are you gonna be posting your notes online so you can review it, or?
I can post it if it's clear to you, but I somehow feel my notes are not that clear. I'll post it for you if you want.
Okay, yeah, it's clear. I can read
Yeah,
it.
I'll do it. I'll do
Yeah,
it.
but what about some of the notes that have been taken in the book? Are you gonna put in like a number showing that where you got these notes from the book, like the example problems you took in earlier?
The thing is, these are all examples. Whatever I do in the class, these are examples from section 2.1, 2.2. So whatever section I'm doing, it's examples from there. But
Okay.
it's just that it's not in the book. They're not writing notes like this. There's a different way of explaining. I'm just explaining it in my way. I write it in the easy language. So most probably if you want to make notes, it's good. I'll post this. So if you want to go through this, you can.
Okay.
Yeah.
Okay.
Yeah.
Thank you.
Yeah,
Thank
you're
you.
welcome. You're
Have a good
welcome.
day.
Take care. Have a good day.
Thank you.
Yeah, you have a good day. Yes. Anyone else has any doubts? Perfect.